Hello everybody, welcome to Gregg's Vintage Workshop, where I'm restoring history one piece at a time. Tonight we're going to take the final look at the Fluke multimeter 8030a that I got from Bill, the old 64 goat. So in part one, I took it apart, I recapped it, I cleaned up the outside of it, and that's kind of where I left it. In part two, I'm going to see if I can get it working, both with an AC cord as well as the batteries. And I'm not going to ruin it for you whether or not I get it working or not. Otherwise you won't watch the video to the end. So without further ado, we will look at part two, and I may get it operational, but I'm not going to spoil it for you. I may not. I'm not going to spoil it for you. Just have to wait and see. So anyway, without further ado, here is part two of the Fluke multimeter 8030a. Okay everybody, this is what we've got. I've got it all back together again. And what I've done is I haven't done anything with the battery terminals yet. And the reason I haven't is because I decided I didn't want to waste a bunch of time doing that if it's not going to work anyway. So what I did do is created a power supply for it. So if you look over here on the side, we're plugged into the power supply, which is no more than a 6-volt wall wart. I had to convert a wall wart to a plug that I could get to plug into it. So there's a little microsurgery here on the cord, but it turned out really well. I had to also reduce the diameter of the rubber. I had to trim it back about 1/4 of an inch and reduce the diameter. So then I did some shrink wrap on it. I got the label. I don't know how well you can see that. Probably not very well, but I got the label all glued back down. It was coming off, it was bent. I straightened it out, glued it back down. We'll go ahead and plug it back in here. And then over on this side, same thing. I got it straightened out, glued back down. And then you're going to see it upside down because I'm just going to tip this forward. I also did paint the Fluke inside there with my liquid chrome. And that's that. Okay, so I turn it on. I did have it on earlier, and I'll tell you right now, it's not working. I mean, it's working, but it's not working. So let me just show you what I'm meaning by that. Okay, all the buttons. Well, that button's in. Get the buttons all out. There we go. Okay, all the buttons are out now. Now flip it on, and it's on. Showing 3.3. Everything's off right at the moment. I don't have a common lead in it yet, and there's a reason behind that. Now last night when I had the common lead in, all it would show was 1.9999, and as I moved the various buttons, it changed the decimal point. But the 1.999 I believe is showing out of range. Now I haven't read the manual complete because it's big and long. I mean, it's all digital, but I've got it. But I do have it on my tablet. What I was reading in it a little while ago is it has self-test built into it. And there's actually a little port here called a BTRY test, okay? And it has some built-in tests that you only need a lead, positive lead in it. So I'm going to run through those right now. I'm going to put you guys on a tripod and we'll just see if it does anything any different. Because like last night, I might not have been pushing the buttons correctly. I think I was doing them intuitively from what I thought it would be. But no matter what I did, it was like out of range. Which is still making me wonder about that big diode in there. So let me put you guys on a tripod and we'll do some of these tests and see what it does. Okay, so I've got my tablet open. Hopefully it don't shut down on us. I'm reading straight from the tablet. It says connect the red test lead to the volts ohm input terminal, which it's in. Check DC volts operation. Select the volts DC function, which can be this one. Put a negative in front of that. And the 20 volt range. Okay, shifted the decimal point. Insert the probe at the test lead into the BTRY test hole in the bottom of the 8030A. Trying to keep you guys in frame so you can see what's going to go on here. I'm going to put this in the test hole. And nothing. It's not doing nothing. Says the display will indicate the battery voltage between 4 volts and 5.8 volts. Alright, we got nothing. It's not changing at all. Okay. Let's go to the next one. Check the AC volts. Select the volts AC in the 200 millivolt range. So here's AC 200 millivolts. This voltage will be as much as 60 millivolts battery operation or 130 with the battery charger power eliminator's power source. And again, we got nothing. Hasn't changed. Okay. Let me set that down for a second so I can roll up to the next page. Alright. It says due to the charging of the input coupling capacitor, it will take 5-10 seconds for this reading to settle. Check resistance operation. Check resistance function and 2 range. So resistance function, I assume is this one, and 2. Place test probe tip into the milliamp input terminal. Milliamp input terminal would be, now see, we just switched to 1.99. Alright. That's interesting. And it goes away. Select the DC milliamp function and 2 range. Oh, I forgot to do that, didn't I? Select the DC milliamp operation. Select the DC milliamp function and the 2 range. Okay, DC milliamp. DC milliamp. That's milliamp. So I guess we're going to put that in that. Let's test probe into the BTY test. And it goes away. Came back. Says the display will indicate between 0.4 and 0.58 ohm milliamps. The current depends upon the battery voltage measured in step D and E. actually, I had that wrong. Rereading, I'm supposed to be there. Okay, so put the test probe in the milliamp input terminal. Display will indicate okay, we got to back up. See, that's what happens. I can't follow directions. Let's see. Select the resistance function in the 2 range. And the 2 range. Get the volts out. Okay. Place the red test probe tip into the milliamp terminal. Should display 0.100. Connect the red test lead to the milliamp terminal. Select DC milliamp function. And the 2 range. That's what we're on. Place the red test on the BTY thing. Okay. Nada. Okay, check diode test operation. Check the diode test function in the 2 range. Select diode test and the 2 range, which it is. Place the red in the milliamp, which it is. Supposed to move this back to volt ohms. Place the test probe into this one. Should display 100 plus or minus 2 digits. As you can see, it's just doing 1999. Select the 200 ohm range. Should indicate approximately 990. Okay, that's it. That's what it's got. And as you see now, that's working properly. So that's really all I was getting last night. Turn it off, back on. Goes to 6.5. I think it was something less than that earlier. And it starts flashing. So that's why I didn't want to fix the tabs in the battery unless it actually worked. There's no sense wasting my time on that. So something not right internally, and that one diode keeps haunting me as a possible issue, because it looked like I was on both the side of the trace that I needed to be on and the top edge of it, and it didn't seem to matter how I tested it. It seemed to pass my meter continuity test. So I think I'm going to go ahead and pull it back apart, and I might see if I can see what size that diode is. If I have one, I may just try and replace that diode just to see if it makes a difference. Nothing else looks burned up in this thing at all. So let me do that. Let me see if I can see what it is. I'll be back. Okay, so I was doing some reading in the manual, and I was doing some circuit checking. I haven't actually physically taken it back apart yet, but I don't know if you guys can see this or not. It's kind of shining in your face so you can't see it. But that diode that I said I checked that didn't appear to be working like a diode was CR3 right here. It's the diode for a bridge rectifier, CR4. So CR3 was the one I was checking. It's a great big sucker. And like I said, it didn't seem to matter how I passed through it. It passed through it. So I'm starting to wonder if CR3 and CR4 might be bad. Now, this is a pretty convoluted schematic for a hack like me to go through, but I think I might start there. Unfortunately, I don't have the not the MOSFET, but the bridge rectifier. I almost bought me some of those. I don't know, it would have been the right size anyway, but anyway, let me take a look at this a little bit closer. Alright, so just a quick update. I've been working on this thing, checking all the resistors, checking everything I could find to check. I wasn't having much luck. And then on a whim, I decided to try something. Looking at the schematic, which I had the schematic out, I wasn't getting my 5 volts to my test port. And there was a switch S11, which is this switch, and there's a switch S12, which is this switch down here. And I never could ever see that having continuity through it. So on a whim, I took a couple of my little Sharpie type tools here, picks, and I put a little wedge of wood underneath the contact there to put some pressure up on it. And when I did that, now it's working. Now it's not 100% working accurate, but it is working. So I feel like I got something accomplished there. I'm going to go ahead and put it back together again, because I know that when it's all buckled up and buttoned up, the resistance values and the values are different. So I'm going to do that and see what I get. And if I can get it to work the way it's supposed to work even better, then I might open it back up and do something a little bit more permanent with that switch. But anyway, I wanted to bring you guys back and show you that. Okay, let me show you what I've done here. So I had this holder, had a few of these holders. I cut the spring section out of this one. I shaved it down so that it would slide into the slot. There's a slot here and there's a slot here. I beveled the edge and I slid it down in there super tight. It's in there. I didn't have to glue it or anything. I'm going to do the same thing on this side. These batteries are going like this, negative to positive. The big end's going to go here, like that. So I'll do the same thing for this side, and the spring will be here. We'll get that in there, and that should work for the batteries. I'll bring you back. Okay, so this is what we wound up with. That one has the wire that runs down the side there, on that side. That one had to be soldered to the one next to it, so this runs in series. Everything looks pretty freaking good to me. Let's get the batteries in and see what it looks like. Okay, there it is with the batteries in it. They're a little crooked, but when the other piece goes on, it'll tighten them up. Alright guys, I've got it together. As you can see, there's no power cords. It's running on battery right now. And I'm looking at, it's flashing 19.99 right at the moment. It looks like on the camera, it looks like it's cycling, but it's really not. It's just flashing on and off. 19.99. Right now I've got it on the K ohm scale, and I got a 15K resistors here. Alright, I'm going to hook it up to a 15K resistor, and it's reading 15 point, whoop, you can see what I'm doing here, 15.06. That's pretty freaking close. Alright. Put this resistor down. Let's grab, let's see, I'm on the 20K. Let's take it to 200K. And I'll grab, let's see, a 180K right here. Grab a 180K and see what it does. Keep from bumping the camera here. Alright, here we go. 180, whoop, lost my spot there. 180.4, 3, 2, 1, 180. 179, 180. That's pretty freaking close. I'm pretty happy with that. Alright, now let's grab something different. Let's go to, let's put it on the 2000 scale here. And let's grab a 470. Grab a 470K here. Let's see what it does with that. Alright, here we go, getting ready to touch. Here we go, 413, 409. Okay, so not quite as accurate on that one. Let's try a different one in that same bunch. Let's see if I can get my probe on there better. There we go. And it started out 441, dropped down to around 400. Alright, so okay, it's not quite as accurate there. I realize I haven't done anything to this thing to calibrate it, and this thing requires some different not techniques, but different sorts of tools to be able to set the calibration, because you're supposed to input like 0.019 of a DC volt and stuff like that. So I don't have anything that is that fine and accurate, so it's not like I can adjust this thing. If any of my viewers would like to adjust it for me, just chime in, because I don't have anything myself I can do it with. Alright, so that's the resistors. Putting these away. Let's see. I'm going to grab something a little smaller. Let's go, let's get out of the K ohm. And let's just go to 200 ohm. And see what happens. Let's grab here's a 56 ohm resistor and see if it, oop, it just fell on the floor. Let's see if it measures it. Moose, get away from that. Alright, here it is, 56 ohm. 55.4. 55.9, 56. Pretty good. Pretty happy with that. The one thing I am noticing is that the one is brighter than the rest of them, and it's still slightly showing up when it's checking the ohms, but it's like it's not supposed to be there, but it's still bleeding through. So alright, so that was a 56 ohm. Let's try some AC voltage. So put it on AC, and we'll put it on let's put it on 200. AC 200. I'm going to plug it into my variac up here, which is on, and let's see what we get. Should be about 122, 123, somewhere in there. There it is, 121.9.8. Sweet. Let me turn it down the variac and see what happens. Turn it down. Yep. It's dropping just like it should. Sweet. Alright, so this is looking pretty good. There's 122, 121. Alright, let me turn that off. Sorry I bumped the camera. Let's get, need something in DC volts. Well, here I got my little homemade little inaccurate power supply, DC power supply here. That one. And let's turn it on. We're on, let's put it on DC. We'll put it on 20 volt, 20, and let's put it in my 5 volt jack. 4.8. What about my 12 volt jack? 12.15. How about my 3.3 volt jack? Yeah, 2.98. Well, I'm pretty happy with that. Anyway, I want to show you guys that the Fluke is working. I painted in my Fluke letters and straightened out the bent up labeling, both sides. So works with power supply, but I'd rather have it with the batteries. So I guess we're going to call this one a wrap. Bill, thank you for the Fluke 8030a multimeter. I've got it functional once again. It is not calibrated, but it's as good as it can be for me because I don't have the tools to calibrate it. But very happy. So from Gregg at Gregg's Vintage Workshop, where I'm trying to restore history one piece at a time, I thank you for watching. This is part 2 of this Fluke 8030a multimeter. And until next time, I wish you all well. Be safe.